Yeah, so I am would like to get a tape of this. This was kind of a fun little thing to put together yesterday. I've been working on commissioning inside of Kaiser for 10 years, and so this kind of gave me a chance to go back and look through some of the stuff that we've published internally over a period of time and sort of reflect on our program and what our journey's been. So yeah, interested to share it. By the way, interrupt me all over the place and ask questions along you go. There's a lot of, you guys work for big companies, so there's a lot of Kaiser speak in here, and so if you don't know what I'm talking about, then please uh, interrupt me. Anyway, we do I'll get the bragging out of the way first, and then I'm going to show you a bunch of dirty laundry. But we do consider this to be the industry leading commissioning standard or industry leading commissioning program, and we try not to just say that without having something behind it. We have looked around and benchmarked with some other sort of significant commissioning programs that we're aware of. A lot of them are government agencies that have commissioning programs. And so we do think that we have a world leading program. That was my boss's charge, was that we should have a world leading commissioning standard and a world leading commissioning program. And so the basic elements of the program that I'll show you here in the beginning are that we have pretty good documentation around our commissioning requirements. We do have some pretty good contract templates to support the commissioning milestones. Namely, in our contracts, commissioning is supposed to be done by substantial completion and then final completion. And so we have that written down in enforceable language. We have a central filing system for all the commissioning deliverables. So every commissioning report that comes in within Kaiser goes onto eBuilder, and my team can see it. We have a review, which is my team. So we have an internal review of all the commissioning deliverables, and we have a litmus test to say whether or not the commissioning on a project was successful or not successful, whether it met our standards or not. And so that gives us some program-wide tracking. I'll show you some program-wide numbers here in a little bit. And then as of right now, we have some technological elements that I'll get into as we get further on. So the first one, I'm going to go through these sort of five straight away. The first one is our documentation of the commissioning requirements. We used to have a commissioning standard that was pretty broad. It said any project that had any of these things in it should be doing commissioning. So it was just like a very wide net that turned out to be unenforceable. And so now we actually go, every project that happens in Kaiser, we send it through this test in the beginning and we look for the projects that we don't want to check commissioning or where we don't require commissioning. And so there is a pretty good list of projects where we're not doing commissioning, and that's a little bit easier to manage that way. So we manage by exclusion. We look at all the projects, and my team literally looks at the name and the scope of each project, and then our goal is to put as many projects as we can into the we're not checking these list, because we like to do less work.
Hey, Travis, you said to interrupt you and ask questions, so
Yep.
I'm going to do that. Did you look at dollar value for this as well?
That's a great question, and we used to have a dollar threshold on this, and we have eliminated that dollar threshold actually fairly recently. There still is kind of a practical dollar threshold. We have this one that says tenant improvements was less than 10 zones, or so rooftop package units less than 10 zones, or single zone units, that sort of thing. Those projects will be under about 50 grand. And so practically speaking, there's not many projects under 50 grand where we require commissioning. I should say right up front that our commissioning is not necessarily third-party commissioning. In fact, on the smaller projects, projects under 10 million, we encourage commissioning within the project team. So we're actually pretty strong encouragers of that. Okay, so we do have the contract language to support the commissioning milestone. In our contracts to the general contractors, it has this language that certificate of substantial completion is withheld until commissioning is complete. There's final payment that doesn't get paid until commissioning is complete, and the commissioning report is posted. That's posted, not approved. So the commissioning report has to be up. My team still does some review of that and may or may not accept it, but it does have to be posted before final payment. And then retention is also not paid until that commissioning report is posted. These things are, you guys probably know, these things are in our contracts, which means that our project managers and our contracts administrators can enforce them, but actually enforcing them has proved to be immensely challenging. And so we're actually kind of going through some rethinking around that. To be blunt about it, we haven't had a single major project that's actually successfully completed commissioning requirements at the time of substantial completion. So all of our major projects are either delaying substantial completion on account of commissioning, or they're issuing substantial completion without commissioning complete, and then we're sort of going back and trying to get commissioning done. So that's enough there. We do have central filing of commissioning deliverables. Kaiser uses eBuilder. I'm sure y'all use something else, but they're probably all, similar versions of chocolate. So the one that we use is eBuilder, but within eBuilder, our file system has, folder 8 and folder 8.01, which is the commissioning folder. And so our mantra since 2018 is if it's not in eBuilder, it doesn't count. So if your PM says, oh, I filed a commissioning report on this, yes, well, if it's not sitting in the folder, if it's not called the final commissioning report, then it doesn't count. As far as we're concerned, you didn't file it. And then we have what I call the litmus test, or my team actually does a check on every commissioning report that we receive. And the litmus test is part of the checklist that you see right there has, I think, 9 items on it. But the litmus test items there's 4 of them. So number 1, the commissioning report has to include an issues log. We don't believe you if you say that there was no issues. So the commissioning report has to include an issues log. Secondly, the commissioning report has to include some documentation that all the issues on the issues log got closed. Third, you have to include trending analysis, not necessarily for electrical projects or some of the non-trending projects. But anywhere something needs to be trended, it has to be trended. And then finally, the trending has to show that the systems are working according to their design intent. So those are our 4 litmus tests, and you have to pass all 4 of those in order for us to call the commissioning report successful. As I was going through this, I did have to look. We adopted eBuilder in 2017. And so prior to that, we did not have the central filing system where we could see every commissioning report that was coming in. And my team, some of my guys in Northern California refer to that as the dark ages. We did spend a lot of time on the commissioning program where we had a lot of process maps, and we would literally call project managers and ask them to send us a copy of the commissioning report and things like that. And those were very dark times. We didn't get a lot of commissioning reports into our hands to actually take a look at. And when we did, the quality of those was, well, we'll see some numbers here. So the first year that we actually had eBuilder implemented, and we were able to see the commissioning reports filed in eBuilder, and then we were able to check those commissioning reports. These are what the numbers look like. So I think there was 143 projects where commissioning was required according to our standards, and the actual number of projects that passed in terms of A, filing a commissioning report, and B, passing the litmus test on the commissioning report was 4. So in other words, the results were terrible, just absolutely terrible. And so the big gaps were, we would have a lot of projects where we knew at this period of time, we just didn't, you'll see that commissioning status unknown. In later years, they're either filed or not filed. But the unknown was, we tried to reach out to the project manager and see if they were filing one. The no CX report means that we actually confirmed that, no, we're not going to file a commissioning report on this project. But then once we got commissioning reports, we had a significant number of projects where they would have an issues log, there would be issues on the projects, and the final commissioning report would literally say, there's issues on this project. We recommend that you open a new project to solve the issues that are still on this project. And that's a huge problem. That's still a big problem that we see in our commissioning reports. And of course, lack of validation is even worse than that. So then we go to 2019. This gets quite a bit better, and it got better relatively quickly. So the lack of commissioning reports, that fell off pretty quickly, at least in the first year. I think some of that's actually come back. You'll see some of that come back. And then our litmus test, we eased up on the litmus test, I think, in 2019. We have gotten a little progressively sort of tougher on that. But here, even here, you're talking about 57% of projects that actually had acceptable commissioning. This is 2020, so now we're down to 44% of projects that actually had acceptable commissioning. This is 2021, we're closer to 2/3. And this is kind of, these are the numbers that we're at right now. My boss is still saying, you know, we should be 100% on this. If we require commissioning, and by the way, we pay good commissioning fees when we do have commissioning. And so this kind of should be 100%, but we still have projects that don't file commissioning reports. And then we still have projects where there's issues outstanding or the trending doesn't happen. Last year, 2022, we actually were required to, or were asked to add an element into our tracking, and that element was the element of timeliness. And so that was not only, so now we're tracking successful commissioning reports, but we're also tracking successful commissioning reports where we're actually getting that report in and approved within 45 days of that substantial completion marker. So that makes things sort of, you can see there's a big chunk down here where we have, you know, 47% of our commissioning reports that we got were successful and timely, but there's another big chunk there, 32%, where they are ultimately successful, but they can take 90 days, 120 days. It can take a long time. We've had commissioning reports that hang out there for a year before they ultimately achieve what we call successful commissioning. And then, of course, we still have some that are unsuccessful. So I'll go into some of the program elements here that we currently, these are things that we've developed that we basically offer to our commissioning agents and to our commissioning teams. The first one are these template acceptance criteria. We started doing template acceptance criteria in 2017 and 2018. So we've had a published document on this since about then. We share that document pretty broadly throughout the industry. So anybody wants it, I think you're welcome to it. We have starting in 2020, our commissioning standard in 2020 implemented connected commissioning, and basically controls design responsibility for the commissioning agent. We got sick of hearing what we would always hear is we have an engineer of record that did the controls design. The commissioning agent would issue comments on the controls design, a bunch of critiques of the controls design, and then those comments wouldn't get picked up, and then we'd find ourselves at the end of commissioning, and you'd have a commissioning agent with a smug look on his face saying, "Oh, see, I told you so. All of my comments on the design, you know, came true." And we said, well, that absolutely defeats the purpose of even having you on the job. And so from now on, our commissioning agents stamp and sign the controls drawings. They're allowed to co-stamp and co-sign the controls drawings with the engineer of record, but they do have a design responsibility for that. There's no more comments. There's no more sort of issues. It's either you're either in or get out. And so we did have to rewrite our professional service agreements to commissioning agents there. We also, starting in 2020, required connected commissioning for projects. So when we're doing trending, it's no longer acceptable to email spreadsheets of trend data back and forth. You have to have a connected commissioning program where you're looking at data real time and doing data analytics real time. So we do have, we did quite a bit of work on the contracts. We have a professional service agreement for commissioning agents that includes all that. That includes the design stuff and the connected commissioning stuff. And then we have a bunch of work authorizations for any type of project. We have some standard work authorizations, basically just scope templates that our project managers and contract administrators can push out on, they need paper to push out on projects. In 2021, we revised that acceptance criteria standard. So now we're very specific about what the design engineer and the commissioning team have to put together in acceptance criteria. And then also, you kind of can't see it because I put the slide over it. There's an acceptance criteria change process. What we've seen happen a lot is that during design, a team will establish an acceptance criteria, and then you get to commissioning and wildly fail that acceptance criteria. And then you'll get an email from the commissioning agent to the engineer of record that says, hey, it actually looks like this. Is this okay? And the engineer of record said, yeah, that's fine. And then they sign off on the project. And so we now have this acceptance criteria change process. Like, okay, if the fan power was supposed to be 0.2 watts a square foot, why are we accepting 1? And and so we've had quite a bit of turn in that. We also have for our new projects, we use a monitoring-based commissioning program, a fault detection program called Clockworks. That's another national contract that we have. And we have what we call the clean bill of health, where the basic idea here is that if you buy a new car and you drive it off the lot, the engine lights shouldn't be on. So if you buy a new building and it's brand new and it has brand new control system, then everything should be working and functioning correctly. This is a way to measure that with the clean bill of health. So there can't be, there's 3 types of faults. There's energy faults, comfort fault, and maintenance faults. And we've set up, there can only be a certain number of faults per 1,000 square foot that happen within that system to sort of, it's a brand new building. It should be running great. So that takes us into kind of the topic that I think most of us are interested in, frankly, that I'm interested in, that is the relationship between commissioning and energy, the relationship between commissioning and energy performance. I've said before that I do believe that commissioning is a vital piece of an energy program and a building energy program. But I believe that as a matter of faith, the evidence to back that up is not good. I'm going to show you that, but I want you to know that I continue to believe that commissioning is a vital tool within a building energy program, even though sometimes the evidence doesn't justify that or even points the other way in some cases. So the first
big Travis,
yes, sir.
Question for you. Hey, great stuff so far. Just to back up to the Clockworks that you've got,
Yes,
the fault analytics. Are you successful in including that in the capital ask for the project, or is that like the first thing cut when you've got you're over budget for the capital project?
We have been successful in including it in the capital. It's actually cheap. It's quite cheap. So I think for us, not to give away their market numbers, but for deployment of the fault detection software and the first year of service, we've got that down around 5 or 7 cents a square foot. So it's not a big number at all. And so, yeah, so when we're doing, I think our standard says if you're spending more than $250,000 in controls, then you have to do Clockworks. And at that point, it's such a marginal cost that it doesn't get VE'd out. And also to defend it, we have had to defend it to property accounting. Is this actually an asset? Is this a capital asset? And we do so simply by saying that this is a component of the building that's necessary to see that the building is working correctly. So it's an asset in the same way that a speedometer is an asset on a car, right?
Gotcha.
So
okay.
We've had both those.
Have you standardized on a building automation system also, or is that out for bid to the lowest bidder?
A little bit of both. So we do have, for new construction, we have standards. And there's basically JCI, there's Johnson Controls, and then there's Tritium Niagara. The Tritium Niagara being a pool where everybody can play in, and there can be multiple vendors and bidders within there. And so those are our standards for new construction. Of course, a lot of our work is happening in the existing buildings, and so we do have whatever control system we inherit with those. We have some standards. We do have a national standard directive to move towards open systems and basically towards that Clockworks and or Tritium Niagara system. But it's restricted in capital. We can't, it's not a blank check. So there, we have to take steps towards the standardization of the control system with each project. But we don't get to, just rip out and replace control systems, cost what may, right?
Yeah, we have found that while Tritium is a great hardware and a great system, so many different people can install it and program it. That's where we ran into our issues with vendors bidding the Tritium system, but they're not really good in it. So we've had to really kind of list the vendors that can install it in addition to just listing the system.
Yep, we our experience is similar.
Yeah. All right. Thanks.
Yeah. Okay, so into commissioning and energy, I'll talk about new construction first, and then I'll talk about some of our plant maintenance programs. The new construction side, we've been asking for energy models since I started, but for quite a while. So since about 2014, we've always asked our design engineers to do energy models. These are the medical office buildings, and so what we've discovered very plainly is what is referred to as the energy performance gap. The energy performance gap being the delta between what the model says the building's going to do and what the building actually does. So there's actually now, I think in ASHRAE, not so much in ASHRAE, but in some of the national Lawrence Berkeley labs and stuff like that, there's some papers coming out on energy performance gap, what causes the energy performance gap, how can we reduce the energy performance gap. The bottom line being that energy models themselves are pretty inaccurate tools, and that there's some wild opportunities for inaccuracies. So this was a slide that we put together a couple of years ago. This is our average, our best and worst performers in terms of accuracy and in terms of actual performance. Average error on an energy model is 50%. We've had some that are over by double. We have had buildings that actually come right within 10% of their energy model. That's rare, but it's getting closer. And so we've really had an emphasis and a focus with our design engineers on accuracy and trying to gain accuracy within the energy modeling process. I'm a big believer in energy modeling, even though right now it's not a very accurate tool. So we're trying to.
Do you ever use a third-party energy modeler, or do you always use the design engineers?
Yeah, we've done that on some of the major projects, the larger hospital projects. We had the design team model, and then we had an independent third-party model. Honestly, in that case, that didn't help the accuracy effort. And some of these have also been third-party energy models. I don't know that helps the accuracy effort. My opinion is the root problem of the accuracy, or the root of the accuracy problem, is that our design engineers, the Mazzettis of the world or whatever, they're not really in tune with the actual load profiles that happen inside of the building over the course of the day. And so we've tried to spend some time calling that data out of our building portfolio and going in on education for those design profile, or for those profiles, to try to get that accuracy in place. This is just MOBs, by the way. We've opened 2 hospitals in the same time frame. The first hospital that we opened was off by about 60% and stayed off by about 60% from its energy model. The one that we have just opened, San Marcos, is one of the ones that's right around 10%. And that was one where we really did spend the time on those profiles. So we gathered plug load data from existing hospitals and fed that to the design team and tried to get that into the energy model to improve the accuracy. That seems to be working, but it's too soon to tell you anything.
The other question I have here, Travis, is what is the time frame of your actual? Is this 18 months after? Is this 12 months after?
Yeah, it's an annual, and so we'll look at the annual. If there's spread in the annual, then we will look at, I think this was all current year when I ran the model. But we try to give it credit if the first year was close to the energy model. More often than not, by the way, that happens the other way. The first year will be really high, and then the next years will come down.
That's what we see too.
Yeah,
that same trend.
Go ahead.
I was going to ask about the actual two, and I think we kind of see two actuals. There's the one for the building as delivered by the project team, and then there's the one after our internal POM energy team has gone in and done everything they need to do to make the building as efficient as it can be.
Right.
So without that internal team, though, we would be with the building as delivered.
Right.
I concur with Michael exactly. That's exactly what we see too.
That's interesting. We often don't have that, and these are medical office buildings. So, particularly in the case of medical office buildings, we really don't have that. Our facilities operators take them over, and they just start answering complaints.
Right.
They don't do an optimization round. That's an interesting idea. Anyway, what I think we've learned for sure is that natural gas is a culprit. We know that when it comes to accuracy, energy modeling, prediction, and the actual natural gas is far more often wrong than it's right. So we've seen huge errors on natural gas. The average is 147. The worst case being a factor of 5. And we kind of know some of the causes of that. We've done some studies on boilers in particular and boiler plants in particular. I think our design community likes to specify, and even our codes will say, hey, specify a high efficiency condensing boiler, and that's the answer. And so this was one where we specified a high efficiency condensing boiler, and then we went in and actually we had the gas metering and the BTU metering in place, so we measured the actual system efficiency. And that 94% boiler had some actual efficiencies closer to 30%. So it has everything to do with the system design and how that system is designed to flow and turn down and delta T's and all that stuff, which frankly our design engineers are just not at all good at designing those hydronic systems in a way that 94% is realizable. So we're really tough on boiler systems and really tough on heating hot water hydronic systems during the design frame. The other thing I think we've learned about energy modeling is that the units on energy modeling are often terrible. We usually talk about energy modeling during design in units of kBTU per year, which is not super useful. It's a whole lot better if you could talk about kBTU per month. And it's even better if you could talk about BTU or watts per hour. And so during our design period, we always ask the design team to publish that 8,760 hour model so that we can look at fan power by hour, cooling power by hour, and then whatever the powers are by hour. And that's what we try to validate during commissioning with our acceptance criteria. That's a huge paradigm shift for the design community. Most design engineers, this was actually a conversation I had at dinner with Walt Vernon at one point. He said, hey, if it's like right now, if it's noon on a Thursday and it's 74 degrees outside, like the design engineer knows how much fan power should be being used, right? Or how much boiler power should be being used in those conditions. And me and a couple of mechanical engineers said, no, we have no idea. And so we've kind of had to force that. We've kind of had to force a very deliberate design. So the mechanical engineer should know if it's October and it's 74 degrees outside and it's 10 in the morning, you should know how much fan power is supposed to be used by your system at that time frame. And then we should measure it against that prediction. And that has been, it's a very different vocabulary than what the design community is used to. But that's kind of what you need to validate stuff. So off of new construction, I'll also talk about what we've seen within the plant maintenance program, commissioning and energy. And so this is actually fairly new. Just about this year, we started tracking energy performance per building and per project. So every project that happens in a building that has a potential energy impact, we go in, we do M&V on that, weather adjusted M&V on that, and we file it under that project number. And so far, we've really just been looking at projects that were completed in 2021, 2022, that sort of thing. And we have projects that show energy savings, right? We can list the energy savings. That's all over here, KBTU, annualized KBTU of savings. What's amazing about that is that the spend and the savings are a complete scatter plot. They're totally unrelated. Even for similar types of projects, that of course is the project manager pushback. Oh, we can't do any, we can't do energy on this project because our budget is limited, right? But what we found is that actually energy savings, when it does happen, tends to happen just by some early smart design decisions, and it's not really associated to cost. It's not a marginal cost to the project. Scatterplot. We also have a whole bunch of projects where there were energy affecting systems and they literally showed zero energy savings. Some of them have been energy, you put in a boiler and the building energy goes up. We have quite a few of those. We call that a zero. And so this is the way that actually looks. So in our plant maintenance program, we do have obviously projects that did commissioning and saved energy. That's in the middle there. That's where the two overlap. But we also have projects that did no commissioning. They also saved energy. And then we have projects that did commissioning and they didn't save energy. So it's not the one-to-one correlation that I would love for it to be. And I think that's someplace where we have to do a whole lot of work. That's actually what my team is working on now. The content that we're pushing out this year, we have this presentation that's called How to Not Save Energy, where we do a bunch of case studies on those projects with zero energy savings. And I think we've come up with a good playbook that basically means, when you have plant maintenance projects, that first off, replacing kind is a bad word around our shop. And so during the assessment, during the initial period, the scoping period, we try to get goals in place. If we can make those goals numeric, so much the better. During design, we try to consider options that actually make a difference. What we see very often, design engineers love to show you, hey, here's three different types of chillers. Here's the Trane chiller, the Carrier chiller, and the York chiller, and then they do a life cycle cost analysis on that, and you go, well, that's crap. All of those are like 5% plus, or that's very marginal differences. So what we want to see are options that actually make a difference. What if we reconfigure the plant? What if we, change some of the variables, change temperatures, stuff like that. And then in design execution, there's a whole bunch of things that we try to look for: shutdown hours, turn down hours, delta T's on those water systems, flow and metering. Very important to include enough metering to validate energy performance. If you're going to do a system that's supposed to save energy, put in the meters that you need during design in order to be able to validate that. And then during commissioning, follow up on that. Include those energy metrics. And then my team has to watch to make sure that when we have acceptance criteria and we have energy metrics, that we don't sign off on that we don't artificially sign off on those projects, that we wait until we actually hit those metrics in order to sign off on the projects. I don't know. That's what I got.
Say, Travis, do you do any commissioning yourself? Does your team actually perform the commissioning on some of these projects?
Do you?
No, we never have.
Does anybody here have internal commissioning? Yeah, I've heard some, like, I know Harvard has an internal commissioning team, and that's no, we don't. We outsource it all.
And who do you assign to that commissioning agent? Is that the maintenance team or the construction team or your team? Who does that?
It's hired by the construction team.
Okay.
so it's always a contract to our construction team, our construction project manager. We're pretty good about getting out in front of it. So like I showed you, we have those stock commissioning scopes. So when a project opens up, if a boiler project pops up onto the Kaiser radar, then I pretty much send my guy out there immediately that says, hey, listen, you're in Fresno, you're doing a boiler project. Here's a standard commissioning scope, and here's 3 people that we know are worth the shit. So we jump out ahead of it pretty quick, but it is contracted to construction. What's up, Anna?
You got it.
One more question. How is the lessons learned from the commissioning translated into the actual maintenance people for that building?
Poorly.
Okay. So
Yeah.
you're the same as us then.
Yeah. That's a big gap. That is. So I've always, I actually work on the capital side. So I'm on the construction side. So my internal clients, my direct internal clients are the project managers. And so the story that I always hear is that, hey, we built it right, we commissioned it, everything was working perfectly, and then Fac Ops got their hands on it and they just screwed everything up, and so my line to them has always been, well, listen, if we built it right and we built it perfectly, then we should have a commissioning report that shows us that everything was working perfectly. And then we can go back and look at it 6 months later and see how they screwed it up. And then I can take action on that. I can go fix that. That's never actually happened. But there are some operational, I don't know, we don't do a good job of communicating a lot of those bases of design to operations. Frankly, that scares me. With like, now we're building everything, it's all heat recovery plant. It's the one that we just opened is fuel cells with the heat recovery chillers and all this cross fueling and stuff. And I'm just terrified that, yeah, I don't understand that system. I don't know how our Fac Ops is going to understand that system on a 10-year basis.
Okay. Does anyone have any more questions for Travis?
I just want to say this was really good. I appreciate the time you put into the presentation, and I like the standards that you put up there that you're using as well for your design standards. So I just want to thank you for your time and putting it together and presenting it today.
Yeah, this wasn't anything original, but I didn't do any work on this for this meeting. We do commissioning community of practice every year. And so I kind of had all these slides from previous years, and we try to post those. By the way, we try to post those on YouTube, so the commissioning agents can always sort of see that. Any commissioning agent that misses the community of practice meeting, we'll just send them the link and have them watch it later, because we want to keep that whole industry informed, right, about where we're at. So
I did want to mention the slide where you had the correlation between commissioning and energy. And I think what came out of it was there's not a good correlation. I would say that buildings that are commissioned, even if they don't have an energy savings, if they are commissioned and they are turned over to the maintenance department in a good working condition, then they have more time to drive the energy savings as time goes on, rather than trying to get the building to operate correctly because it wasn't commissioned.
right. Yeah, and there's always the two sides to that. We've argued about that internally. One is that there's the argument that, well, if you didn't do commissioning, boy, those buildings would be a whole lot worse. They'd be off the stratosphere. But I think the one that I try to press on, particularly on commissioning service providers and design teams, is that very often, if we don't have, or what's the analogy? This guy told me when I ran my first marathon, he said, you can either set a goal to finish the marathon, or you can set a goal to finish the marathon in 4 hours. Both ways, you're probably going to hit your goal, but it's a different training regimen, right? And so very often our commissioning plans and our commissioning OPRs are written just around functional performance, right? Does it start up? Does it, fail the way that it's supposed to fail? Are all the alarms working? It's all just this functional performance stuff. And we omit we omit those energy metrics, those watts per square foot metrics, or those watts per CFM metrics. And if we don't have those goals, similar to the time goal and the running, then yeah, of course, you're not going to hit them. And so I'm of the opinion that it's real important to put those goals in the beginning, and then even if you don't hit them, at least you know where you are relative to that marker, right? So
I've got a follow up on energy modeling, Travis. So one thing that, I know this from doing it myself, and we always hear still from our modelers, is that the software is not designed to be predictive. So I'm wondering if you kind of come up against that. And then also but there are a number of different softwares available. So do you have you found that any particular software, I don't know, IESVE or something like that, is better at predicting than others? Or do you really think that you have just the most success when you are feeding back that real information to
I actually I've faced that question for a lot of years, and we literally reject the premise of that question. And we've had energy modelers that insist on saying that, and we just don't use them anymore. And so we reject the premise. They say, well, energy modeling is not supposed to be predictive. It's supposed to be comparative. You're supposed to compare two options. We just say that is complete horseshit. Why would you want to compare two fictional options to each other? I don't give a crap what the difference is between two fictional options. This is supposed to predict the energy in a building. That's why it was built. And if it's not supposed to predict the energy in a building, then we shouldn't be buying it. We shouldn't be paying for it. And so the energy modelers that we work with are very, when I hear that excuse in a meeting, then make no mistake, I rain fire and brimstone on whoever that energy modeler is. And then they tend not to come back with that anymore. That being said, within our business cases, we also acknowledge that the margin of error on energy modeling is not zero. And so what we used to see a lot is we'd see an energy modeler come in with 6 different options, and they were all within 4 or 5% of each other. And so we're very clear about that. If option number 2 and option number 3 are within 10% of option number 1, they're the same as far as we're concerned, because the margin of error on the energy model is 10 to 15%. And so at that point, we go with the lowest first cost option. And many an engineer will cry and say, oh no, the one that I wanted is, it's 3% better. And you go, no, if you can't beat the margin of error of your own modeling tool, then get out, and that makes it a little tougher as well.